Hey class, welcome to Lab 3 Part 1. Before we dive in, I just want to talk for a minute about why this work that we're going to be doing in this lab is important. So in this lab, we're going to be using Excel's Power Query Editor to clean up a data set. It's based on insurance claims and potential fraud. Now I know some of you might be thinking, wait, I'm going to get into accounting, not insurance claims. Totally fair. But here's the thing, the skills you're about to practice, finding messy data, fixing issues, handling missing values, are foundational to any kind of data analytics work, especially in accounting. Whether you're analyzing transactions, audit logs, or expense reports, you need clean data to get accurate insights. If your data is messy, your results, no matter how fancy your charts or models are, could lead you in the wrong direction. That's where Power Query Editor comes in. It's a super useful tool built right into Excel and Power BI that lets you do things like remove columns, fix data types, fill in missing information, and much more. And the best part, no coding is required. It's just a really intuitive way to get your data cleaned up and ready to go. Now later in this course in Lab 5, we're going to use this clean data set to build a simple machine learning model using a tool called Orange. Orange is beginner friendly and drag and drop, so don't worry if you've never done anything like that before. The goal isn't to turn you into data scientists overnight, it's to give you a feel for how predictive models can help flag things that might be worth taking a closer look at. One last thing before you start. As you work through the Power Query steps, keep track of what you're doing and why. Think of it like leaving breadcrumbs. It'll help you when you write up your report, and it'll show me that you understand each transformation that you're making. Oh, and when you're done in Power Query, make sure to go to the Home tab and click Close and Load so your changes are saved back into Excel. That step's easy to miss, but it's super important because you don't want to lose all that work. As you work through this lab, you'll also run into a few key words that you should know a little bit about. The first one is high cardinality. This describes a column with a categorical variable that has a large number of unique values, like zip codes or maybe car models in our dataset. Too many unique values can cause problems in machine learning models. One-hot encoding. This is how we turn categories like color or gender into numbers so that machine learning models can actually use them. There's a short example here on this introduction to the lab here. I'll explain that in detail when we get to that point in the lab. And then finally, overfitting. This happens when your model gets too focused on weird little patterns in your training data set that don't actually apply more broadly. It might perform great on your current data, but fall apart in the real world. We'll talk more about each of these terms as we go through the lab, but it's a good idea to start becoming familiar with them now. And just so you know, the data set that we're working with in this lab, it came from a website called Mendeley Data, which is a repository for many large data sets that are publicly available. I made some adjustments to better fit our learning goals, but if you're curious, you can check out the original data source using this link here. But that's not the data source that we're using for this lab. I've got the link to our data set right here. Just click on this little arrow to download it, and then we'll open it up in Excel. And then also I provided a data dictionary, and you can use this to help understand the meaning of each of the columns in the data set, and that'll be helpful as we go through and decide what's relevant to predicting fraud, and also as we clean the data set up. So I think I'll get started by downloading these two files and hopping in Excel. And you can see here I've opened up our file in Excel. I just need to click on this Enable Editing to get started. And now that I've done that, now I just need to click anywhere inside of this large table. And then I'm going to click on the Insert tab on the ribbon, and then I'm going to click on Table in the Tables group. Getting an indication about where's the data from your table. It's recognizing the headers and all the data within it, and I just got to make sure that this box is checked for my table has headers, and then click OK. So now Excel recognizes this as a table. You can see that with the column headers, we've got those drop downs for different filters, which we saw in our Intro to Excel lab. And now to get access to the Power Query Editor, just make sure I'm inside of this table, and I'm going to click on my Data tab on the ribbon, and then in the Get and Transform group, I'm going to select From Table or Range. And that's going to bring up the Power Query Editor. So as we take a look at the Power Query Editor, which we actually saw in our Power BI lab in Lab 2, you can see that each of the columns has a little icon next to its label, and that indicates the type of data that is contained within the column, and the software automatically recognized based on the contents. Sometimes usually that's accurate, but sometimes it's not. So we want to take a look at that. I can see right away with this one here that it recognizes ABC, so it recognizes it as text. I can click on that icon to see all the different data types that are used here and what these icons mean. But even though, so the reason why is because it's got the number of months. The person who made the claim was a customer with the insurance company, and it looks like it's got the number and then a space and then the word month. So we'll probably need to do something with that a little bit later. And that's sort of what I want you to do right now, is just sort of pause the video and take a look at all these different variables that exist within this large spreadsheet here in this table. Take a look at all these variables that exist within this table, and maybe get out the data dictionary and make sure you just have a brief understanding of what each of these variables contain. What kind of data? What does it mean? And as you do that, we got to recognize that our goal with this in the end is to help the insurance company predict fraudulent insurance claims. So we're thinking about each of these variables and thinking about whether they're relevant in helping to predict that. We want to think, is the column redundant, biased, or overly specific? Will the column need to be cleaned up, like we saw with that months as customer field, or transformed in some way? So now maybe you've gone through the data set and you made some notes about which variables you might want to remove, which ones might need to be cleaned up, and so on. Now I'm going to talk more about removing some of these columns, which is in step 3 of our lab. So I would suggest that we keep more columns for now. We haven't built any machine learning models yet, so we don't want to remove any columns too aggressively. Columns that seem unhelpful now might become useful when combined with others or transformed in some way. When we get inside of the orange data modeling, you'll be able to test which columns improve model performance. There are some columns, though, that might hurt the model's performance, violate privacy, or may be too messy to work with. Others might be useful later, so once again, let's not remove anything without thinking it through. There are some columns that I want to point out, though. The first one is policy number. Policy number is a random, unique identifier assigned to each insured person's insurance policy. This is just a random number, and it really has no predictive value, and it could lead the machine learning model to learn meaningless patterns. This one, I would argue, is definitely safe to remove. And to do that in the Power Query Editor, I just right-click here at the column heading and select Remove. I remember that the Power Query Editor keeps track of the applied steps, so if I wanted to undo a step, I could just click this red X next to that last step. Another column that I'd consider removing would be the insured person zip code, which I have here. And even though zip codes are represented with numbers, they really are a categorical variable representing locations throughout the world. And if I click on this little drop down arrow next to that one, I can see that there are actually tons of different zip codes represented, and this is actually not showing all of them. If I click on load more, it'll load them all. Those are all my unique ones. There's just too many unique values. And we're going to talk more about one-hot encoding, but one-hot coding would be too difficult and overwhelm the machine learning model if we tried to do that with the zip code. We could group the zip codes into broader regions, but that's beyond the scope of what I want to do in this lab. So for right now, I think I'm just going to right-click on the column heading and remove it. Another variable that I'm going to consider removing is going to be the incident location, which we have here. If we take a look at this, we can see that incident location's a full address, and we've got some inconsistent formatting. If we take a close look at it, sometimes words are like street is spelled out, sometimes drive is spelled out, sometimes it's abbreviated. Also, it's just too specific. It might be useful again with some external tools, maybe putting things into regions again. But for right now, we're just going to remove it. So I'm going to right click and remove that one as well. And then finally, I'm going to remove the column for the automobile model that was involved in the accident. If I click on the drop down here, you can see I have a really large number of different models. It's a little too large of a number of unique values to be beneficial to the machine learning model. We really need a huge data set to be able to do that. And for this variable, I would maybe consider grouping by vehicle type, like SUV or truck and so on. But that's beyond the scope of this lab. Now, if you wanted to do that and you wanted to use maybe a language model like ChatGPT to help you, maybe that would actually work. But for my purposes for this lab, I'm just going to remove this out of here. As I mentioned earlier, as we make changes to this data set, be sure to take notes. If you end up removing more columns than I did there, make sure you take notes about which columns you removed, including the ones I did, and why you removed them. You're going to report on that later. There are a couple other columns that I'm going to briefly talk about here. I'm not going to remove them, but I just want to bring up a couple points with them. For the insured occupation, if I click on the drop down there and sort of look at all the different unique values, looks like there are about 14 of them or so. And it also looks like someone else has gone through and taken what the insured person responded for their occupation and put them into these groups or categories. There's 14 of them, so that's when we talk about one-hot encoding, that seems to be on the edge of where that is usually used. For right now, we're going to keep those. Another one is insured hobbies. There's a pretty large number here as well. It looks like there's a few more than maybe 14. These are potentially predictive. If you think about it, some hobbies might correlate with risk behavior, but also using this risks introducing bias. So we want to be careful with that. And one last one that I'm going to talk about there, you can talk about each of these and think about each of these on your own as well. But one other one that I want to really quickly talk about is the incident date. And at first glimpse, you might think, well, that's not going to be really helpful in predicting whether a particular row is going to be fraudulent or not. Well, there are some things that we could do with this column. What we can do maybe later might be to look at whether the date was during a weekend or during the weekday. We can look at the month of the year, and we know that in Michigan, accidents tend to happen a little bit more in the winter with the slippery roads and stuff. So there are some things that we can do with this incident date column that might help us, the model's predictions. And just to wrap this up, even if you're not sure how to use a column yet or whether you should keep it or not, it's safer to keep them rather than to delete them early. The Orange data mining tool will allow us to test how useful each column is in the prediction model. So just note the columns that you had questions about as flagged for review and include your reasoning. Oh, and one more thing before you finish, there's one column that you definitely don't want to remove, and that's fraud reported. That's our target variable. It's the outcome that we're going to be trying to predict later on when we get into the Orange data mining. So even if it feels tempting to clean it up or drop it like some others, make sure that that column stays in your data set. Without it, we can't train or evaluate any kind of fraud prediction model. So now we're in step 5 of the lab instructions, and since I just mentioned incident and date, that's what we're going to do. We're going to create some new columns based on this date. As we create these columns, make sure that you take note of that for your report, about what we did and why. So the first thing I'm going to do, I'm going to make sure that I select this column. So I'm clicking on the header, and I don't want to change its name though, so I'm just clicking on that column to select it. Then I'm going to the Add Column tab on the ribbon, and I'm going to go over into this From Date and Time group, and I'm going to click on Date, and then I'm going to select Day, and then I'm going to select Name of Day. So what that does is it adds a new column, and I have to scroll way to the right to see it. So it took all those incident dates and it showed us what day of the week that date was on. So now that I see that new column labeled day name, I'm going to select it by clicking the header there, and I'm still in the Add Column tab on the ribbon. Now what I'm going to do is I'm going to select conditional column, and I'm going to create a new column. I have to give it a name, and what this one is going to do is going to look at these days of the week, and it's going to create a new column that either says weekend or weekday for each of these days. So I am going to name it day type. And here is how I work through the logic. So if the column name, so I select that new column, day name, equals Saturday, then the output that I want is going to say weekend. And then I'm going to add a clause, and I'm going to do the same thing but for Sunday. And then finally down here for else, I'm going to have it say weekday. Click OK, and then I can do a little testing here. So I see Sundays identified as weekend. See if I can find a Saturday. Here's a Saturday, weekend, and it looks like the other days of the week are showing up as weekdays. So I did what I wanted. So now that I've done that, I think I'll remove this day name column and right click on the column header and remove. Alright, so now I'm going to go back to that incident date. I'm going to locate it. Here we are. I'm going to select that column header again. And now I'm going to create a new column showing the name of the month that this incident date occurred in. So once again, in the add column area of the ribbon, go to the date button here. I'm going to select month and then name of month. And then I scroll to the far right and I can see, yep, it did that exactly. I've got all of those months there, and that might help us build a better model by looking at in which month the event occurred. Then finally, I'm going to be looking at two different date columns here. So we're going to be looking at incident date, that's when the accident occurred, and then we're also going to be looking at policy bind date, that's when the insured person signed up for this insurance policy. And the logic here is what we're going to do is we're going to calculate the number of days since the policy started until the incident occurred. And that helps identify whether an incident occurred unusually soon after the policy was started, which could be a potential red flag for fraud. So to do this, we need to select both of these columns, and the order in which we select the columns actually has an impact on the calculation. It's going to either show up as a positive number depending on the order in which we select them, because the incident date should occur on or after the policy bind date. So I think I'm going to select incident date first, and then I'm going to hold the control key on my keyboard down. If you have a Mac, you'd hold command control down, and then I'm going to select the policy bind date. So now I'm in the add column area again, click on date, and then I'm going to select subtract days. So I have a new column over here labeled subtraction, and the values are expressed in positive numbers, so it looks like I did properly select those dates in the correct order. If you select them in the opposite order, you'd have the exact same amounts, but they'd all be negative there, or zero, I guess. And since subtraction is not a very good name for this column, I'm going to double click up here and I am going to write a more descriptive label. So I went with days since policy start, hit enter, and there we go. I mentioned at the beginning of the video that there was an issue with this column that's labeled months as customer. We've got numbers and we've got words in there, so we're going to clean that up now. So to do that, I want to select the column header, and then I'm going to select transform on the ribbon. Then I'm looking at the text column group, and I'm going to click on extract, and then I am going to extract the numbers here, and they come before a space in these strings that appear here. So it's 328 space months. So I want to extract the 328 and get rid of everything else. So I'm going to say text before the delimiter. The delimiter is the space, the character that the software is going to recognize. It says, oh, that's where the number starts and ends. So I select that, and the delimiter is a space, just one space. So I'm going to hit the space bar once on my keyboard and then click OK. And I can see, sure enough, the space in the word months were removed. The variable is still being recognized as text in the Power Query Editor though, so I'm going to click on that icon, and these are all going to be whole numbers, so I'm going to select that. And then I should also probably take a look at those new columns that I added, just to make sure that those data types made sense. Actually, it looks like day type, that should be just text. So I'm going to click on that drop down and select text. And then the month name was text, and the number of days since the policy started was whole numbers, which looks good to me. So now we're in step 6 of the lab instructions, and this is where we get some practice with the concept of one-hot encoding of categorical columns. And before I get into that with our data set, I'm just going to do a real simple example here. So I'm going to pull up a blank spreadsheet. Rather than a blank spreadsheet, I've got a spreadsheet that represents the results from a recent poll in which we asked a bunch of students what their favorite color was. So we have a categorical variable here, favorite color. And what we're going to do is we're going to apply the concept of one-hot encoding to this. As I mentioned earlier, machine learning models generally work best when all the inputs are numeric. Some tools like Orange Data Modeling now have widgets that allow them to handle non-numeric inputs, but many models still expect numbers, not text. And one way to convert text categories into numeric form is with this concept of one-hot encoding. So let's say that if we take a look at our data set here, actually I'm going to click on the filter. It looks like there were 6 different choices that people made in terms of their favorite color within the survey. And 6 different choices means that I'm going to create 6 different new columns. So you can see that I've come up with those 6 columns here based on those 6 different color choices. Favorite color was red, favorite was green, and so on. So this first value from the survey of data, the person said red was their favorite color. So what I'm going to do is I'm going to put a 1 into this column for favorite red, and then all these other cells get a 0. And I do that same kind of thing with the second value. So the second person responded they love green. So favorite red gets a 0, favorite green gets a 1, and all the other cells end up with a 0. Same kind of thing with the third value. The third person selected blue as their favorite color. So favorite red, 0, favorite green, 0, favorite blue, 1, and the other cells get zeros entered into them. So you can see manually this would take a long time and it would be error prone. Fortunately, the Power Query Editor has some tools that will help us with this, and even more powerful tools in Orange Data Mining to help with this one-hot encoding. But we're taking these categorical values that were given by our respondents, and we're encoding them in a binary way so that the machine learning model can use that information. One last thing to mention before I apply this inside of the Power Query Editor is that if a column has a lot of unique values, like in our data set, the car models or the zip codes, one-hot encoding will create too many columns and may hurt the model's performance because our data set isn't quite large enough. A good rule of thumb is that if you have fewer than 10 to 15 unique values, that one-hot encoding might be a good idea. But if you have more than 20, you consider grouping the unique values or excluding the column in the model. So now we're going to try it. So we're back in the Power Query Editor looking at our data set that has already been cleaned up a little bit. And I'm looking for a column labeled incident type. So I found it here, and if I click on the drop down arrow, I click load more, I can see that there's 4 different values that were included in our data set. So to start the one-hot encoding, I make sure that I select the column header, and then I'm going to go to the Add Column tab on the ribbon, and then in the General group, I'm going to select Column from Examples, and then From Selections. It's going to create a new column, and it's looking at the data values that are inside of the incident type column. So now what I do is I look at each of these unique values. There are 4 of them. So the first one I see right here in the list is single vehicle collision. So what I'm going to do is I'm going to type a number 1 in that row next to single vehicle collision, and I'll move my cursor down to the next cell, and this next one, it says vehicle theft, so I'm going to enter a 0 there. Alright, so now it's starting to do stuff. So now if I take a look at what it's doing, so every time single vehicle collision showed up, it shows a 1, and every time vehicle theft, which I coded as a 0, shows up, it shows a 0. So now I'm looking for something new. So okay, here multi-vehicle collision, which I can also see that it's something new because it has null next to it. So I'm going to put a 0 next to that as well, because right now I'm just focused on the single vehicle collision column. So everything else is going to get a 0. So it looks like we got our 4th example there, a parked car. That's going to end up with a 0 as well. So now if I scroll down, I've covered all the bases. I've got 1s next to the single vehicle collisions and 0 next to everything else. I'm going to click the OK button, and then I'm going to go over and I'm going to rename that column. So if I remember what I was doing there, that was the 1s were for the single vehicle collisions. So I'm going to right click the column heading here and rename, and I'm going to indicate that. And now that I've done that, I've noticed that the system has identified this as a decimal value and not a whole number. So it's zeros, it's binary whole numbers. So I'm going to click on that icon and I'm going to change that to whole numbers. All right, so now I'm going to repeat that for all the different incident types. So we had single vehicle, and we had multiple vehicle, and so on. So we're going to go just down our list to make sure we cover all 4 of those. So it looks like the next one was vehicle theft. So once again, I'm going to select the column. I'm on the add column tab on the ribbon, column from examples, from selection. And now the one that I'm focusing in on is the second one in the list, because I've already dealt with single vehicle collision. So now I'm just focused on vehicle theft. So that's going to get the 1. And then everything else is going to get a 0. And the quick way to do it is just look for nulls over here. So that's going to get a 0. Got another null there, that gets a 0. And then that's it, because there are only 4 possible values. And since the 1s represent vehicle thefts, that's what this column is going to be named. I click OK, and then I rename it. Once again, I change the data type to whole number. And then basically I'm going to repeat for the other 2 incident types. And if I look over here, I can see that's multiple vehicle and parked car, the 2 that remain. So basically you're just going to repeat that process and pause the video a minute and take care of that, and I'll come back. So now that I've done that for all the different possible values within that collision type column, you can see I've got all 4 of them here. What I should see when I look at each row is that there should be a 1 in one of the 4 columns and 0s in the remaining 3. That's an indicator that I did everything correctly, which looks like I did. So I'm ready to move on. And remember that if you make a mistake with this, you can always click this red X to remove your prior step. So if you accidentally did something you didn't want to, or didn't do it exactly how it was supposed to be done. So for this lab, you don't have to worry about one-hot encoding any other columns besides that one. I just want you to show me that you understood this idea by applying it to that column. Do what we did in the video here. When we get into our lab 5, we use the orange data mining. We're going to use one of the built-in widgets to really speed that process up. But it's an important concept to understand, and I want you to try it once so you really understand it in case you ever encounter a tool that doesn't automate this step. In your write-up about the one-hot encoding, you should write up about which columns would be good candidates for it and which ones might not. So now we're in step 7 of lab instruction, and we're talking about missing values, nulls, if you will. Most machine learning models, including Orange, require you to handle missing data before you build out the machine model. We're going to be taking a look at which columns have null values, and we're going to determine what to do with them. Any decisions that we make here should be documented so that we can write it up in our report for submission. So the first thing I'm going to have you do is get into the View tab on the ribbon, and in this Data Preview group there's a checkbox for column quality. Really helpful little tool here. And what that does, it looks at all the values within each column, and it tells you the percentage that are valid, the percentage that are in error, the percentage that are empty, which are null values that we're looking out for. So I'm just sort of scanning these and see, okay, here we have here, it tells me that with the umbrella limit, if I mouse over this report, 999 of the values were valid and 1 was empty. So we do have 1 null value there. And then if I keep moving around, it looks like most of them are good. Okay, here, collision type, we're seeing that there are quite a few null values there. And keep moving. All right, so now property damage, yeah, a really big number, and the same thing for police report, a really big number of null values there as well. So if we pull up our data dictionary that we looked at earlier, we can get our definitions of each of these columns. I can see here the definition of umbrella limit says it's the maximum additional coverage limit provided by umbrella policy. And we don't need to know too much about insurance terms here, but basically that's additional liability coverage that the insured person had. And thinking about that column in our data set here, there was only one missing value. Yeah, here it is. There's only one missing value. And with that small number of missing values, just a 1, what we could do with this with nulls is we can just remove the rows that contain them, but we lose all the data within that row if we do that. But since it's only one row and we have a pretty large data set, that might not be a horrible idea. For those other columns where we had a considerable number, I think one of them had 38% of the rows were missing the value. I don't think we'd want to lose 38% of our entire data set, so we'd probably make a different decision if we had a larger number of nulls in this column. In real world scenarios, oftentimes we impute missing values by using the most common value or the mean or median for numeric values if the column's important and we don't want to drop rows. But in this case, since we're only missing one row, I think it makes most sense to just remove it. And also it doesn't make sense to impute it as a 0, like it was just no coverage, because we do have valid 0 values in this column. So I think I'm just going to remove the empty. So one way to do that, if I click on the drop down here for this umbrella limit column, I'm just going to uncheck the box for the nulls. I'm going to filter those out, click OK, and now we have one less row within the data set. So when we do our write-up of this, we're going to talk about why we removed that row from the umbrella limit column, and we should also indicate how many rows were removed. As we saw earlier, other columns that had nulls within them had a more significant number of nulls. Look at 178 nulls here within this column for collision type. And in the real world, I'd probably want to investigate and look at why some of these columns had such a large number of missing values. There might be a logical reason that might shine light on how they should be imputed. But for this column, collision type, we're looking at on the vehicle, is it a rear collision, a side collision, and front collision, and so on. We don't have any more context. We don't know why the data is missing, and we don't want to make assumptions. So what we're going to do here is we're going to replace the nulls with a placeholder. I'm just going to say unknown. So to do that, I right click on the column header, I select replace values. I'm going to type in the word null for the value to find, and then I'm going to type in the word unknown for the value to replace with. And that's what it did. I can see those nulls became unknowns now. And by doing this, this allows the model to treat missingness as a possible signal of fraud. For example, one of the other columns that has a large number of nulls was the police report column, whether a police report was filed or not. Well, if there's no police report filed, but a large amount of property damage is recorded, that combination could suggest unusual or suspicious circumstances. By keeping unknown within that column, we preserve that information and allow the machine learning model to learn from potential patterns within the missing data. So I'm going to do that with those other two columns of property damage and police report available. So here's property damage. Yep, I can see there's a large number of nulls. Once again, just right click on the header, go to replace values, and we're going to replace null with unknown again. And then lastly, we're going to do the same thing with police report available. All right, so we reached our final step here. So before I close this out, I'm going to click the Home tab, and I want to make sure I close and load, and that's going to save the changes that we made. And what it does, it actually creates a new table within the Excel workbook here. You see that we have two tables now. We have the insurance claim, which is our original data set, unmodified. It has all the nulls, and it still has, you know, the values before we did the cleanup. You can see that with the months as customers, still got the word months in there. And then we've got another tab here for another worksheet labeled table, and this is the cleaned up data from the Power Query Editor. All right, so what you're going to be submitting is this Excel file, so make sure that you save it. And you're also going to submit a Word document or a PDF that includes a bunch of information. It's out on the instruction sheet for this lab, but basically which columns you removed and why, any new columns you created, what you called them, what they represented, why you included them, which columns you flagged for review and your reasoning for that, how you handled the null values and your rationale, and which columns you manually encoded and which ones you would want to do one-hot encoding on within Orange. And then also something else that I didn't bring up yet in this video, but were there any features or columns that that you might see a legal or ethical concern with, something like maybe gender? In other words, just because a variable is available doesn't always mean that it's appropriate or even legal to use. I'm excited to hear how this lab goes, and if you run into any snags or have any questions, please reach out.